Okay, so here we go with prop number 4. Property number 4 of rectangles. All 4 diagonal segments are congruent because the diagonals are congruent and they bisect each other. This is what was talked about on example number 6. So due to how diagonals are bisected and how diagonals are congruent based on rectangle properties, that's where this property comes from. But then if you see this based on what I have here, so I don't have to draw a new diagram, is with these two sides being congruent, we have isosceles triangles. There's an isosceles triangle, and another isosceles triangle. So this also means the triangles created are isosceles. Now, remember with isosceles triangles, you can have lengths of the legs being congruent, which is covered in the first part, or you will have base angles being congruent. So you'll have 2 pairs of angles on the base, the non-congruent side being congruent to each other. So with that, we got some examples. Example number 3. Given that measure of angle ADE is 74 degrees. So measure of angle ADE, okay, ADE is this angle right here, okay? And they want us to find the measure of angle BEC, meaning they want us to find this angle right there. So what we do know is that the diagonals bisect each other, forming congruent lengths. So we have this isosceles triangle, which I'm going to redraw out over here. We have the congruent markings. This is A, this is D, this is E. And this measurement right here is 74 degrees. So with that, we are using reason number 4, isosceles triangle. If D is the measurement of ADE is 74 degrees, now mind you, it's ADE and the other angle would be DAE. I'm pulling it out, I'm just looking at it as angle A. This measure here is also 74 degrees. Once I find the measure of angle AED or DEA, this measurement right here, I can use vertical angles to say that they're congruent. So here's what we got going on algebra-wise. Isosceles triangle adds up to be 180 degrees. Okay, so I have 2 of ADEs because these angles are the same times the measure of angle ADE plus the measure of angle at the top AED, add it to be 180 degrees. So 2 times 74, and I'm going to put the letter X in here. X equals 180. So I get, excuse me, $148 plus X equals 180. So X equals 32. Now, if I was going to find the measure of angle BEC, I have to make sure that I plug it back in. So BEC is that angle that I just found 32 degrees, so measure of angle BEC equals 32 degrees. I apologize, I was at the very bottom of that. So with that, we have another example that is going to build upon another idea of this. So given that measure of angle AEB, so AEB is 144 degrees. Find the measure of angle CAB. So CAB is this one right here. So I'm going to add some red to that too. Okay, so I'm going to redraw this triangle out and look at it, knowing that these are isosceles triangles because the diagonals bisect each other and all four little segments that are part of the diagonals are congruent. Diagram wise, this is E, and if I just flip this down, this would be A, and this would be B. So I know this is 144 degrees, this is congruent, and I want to know the measurement of this angle, which if I put that as a letter, I'm going to put it as X. So, and then also this one would be X as well, because base angles theorem allows me to say that the two base angles, in this case CAB or EAB and EVA, are congruent. So this one is also X. So I'm using isosceles triangles. So measure of angle AEB, excuse me, I said that wrong, AEB plus either 2 times X or X plus X, I'm going to use 2 times X, equals 180. This is 144 plus 2x equals 180. 2x equals 36. X equals 18. Find the measure of CAB. Well, CAB and X are the same thing, so measure of angle CAB equals 18 degrees.